Hello dear friends, today let us discuss some of the very important manufacturing processes. Okay. So, what is manufacturing, why it is important, what are the materials available to do the manufacturing processes, and in this particular class let us discuss some of the important machining operations using one machine and one tool. Yes dear friends, we are using one machine, one tool to do the multiple various operations, machining operations on the material. Let us discuss. I am Dr. K. Vivekananda from ICFAI Foundation for Higher Education, working as an assistant professor there. So, here everyone, irrespective of their engineering stream, it is very important to everyone to understand what is manufacturing, what is the importance of manufacturing process. You can see every day we are using a plate, a ceramic plates, a tablespoons, a coffee cup. Everyone is manufacturing, every product is manufacturing. So, here everyone should have a basic idea about how these products are manufacturing. So, we will see the basics of manufacturing today, and let us in deep discuss the various machining operations. So, here you can see in this class we are going to cover the need of manufacturing. What is the need? What is the importance? That we will discuss today. Let us discuss the requirement. What is the requirement for manufacturing process? If you see a tablespoon, we require some material. Which material is suitable to fabricate or to manufacture the tablespoon? And third one, the classifications of engineering materials. What are the engineering materials available to do this manufacturing process? That is also very important. So, what are the engineering materials available? That we will focus on this class. Then classifications of manufacturing process. What are the classifications? Wide range of machining of manufacturing processes are available today's world. Advanced manufacturing processes also came into the existence. Let us discuss that also. What are the main manufacturing processes are available? Now, the various machining operations. What is machining process? The basic fundamental of that one, and then various machining operations we will look it into. My dear friend, my aim is to convey you, if you want to start a startup, a small scale industry, listen this class very carefully, then you can start your own startup. One machine is enough and one cutting tool is enough to do the multiple operations, which is widely used in a wide range of wide range of applications in wide range of industries. What is the need of manufacturing process? Take a automobile car. My dear friends, let me tell you that more than 200 parts are joined together to construct or to manufacture or to fabricate a automobile car. Let me tell you, if you take a pen, cap is separate, refill is separate, and the body of the pen is separate. So, to manufacture a small pen, you need multiple products to join together. Imagine, my dear friends, you have to manufacture an automobile car, a aerodynamic plane, and you can see the ships, how it will be constructed. It's very, very important to understand these manufacturing techniques, how this all will be constructed. Now, see, I have shown you the beautiful figure, different parts of the automobile car. Different parts of the automobile cars are jointed together. First, it is fabricated or manufactured with the use of multiple operations, and then after this particular products, is joined together to fulfill the need of the human being or humankind. See, the chassis, the seats, okay, the steering, the engine and engine parts, these all are jointed together, and these parts are also manufactured by using different types of manufacturing processes. Now, let us see here the aerodynamic, a aeroplane, how it will be constructed, how the parts has been jointed or how these parts has been manufactured. So everyone has the curiosity to know aeroplane, how aeroplane has been designed, how aeroplane has been manufactured, how aeroplane has been worked, how an automobile car has been manufactured, what is two-stroke engine, what is four-stroke engine, what is the cc, cubic centimeter, what these all are will be coming under the manufacturing process. Once you do the manufacturing process, you understand the manufacturing process, it is very easy, my dear friends, to understand all these things. Now here, what we required for manufacturing? What are the requirement for manufacturing? For easy understanding, let me tell you, there are 5 M's. It's very simple to remember. 5 M's are very important, and that is, first one is material. Of course, if you want to do the manufacturing, something we need. That may be a plastic, that may be a steel, that may be a iron, whatever. We need a material. And second one is method. It's very important to choose a proper method. R.K. Jain, Professor R.K. Jain, in his textbook called Production Technology, in his book, the first letter, first sentence, he will start like this: it is the duty of an engineer to bring the new thoughts and designs into reality by proper selection of machine, method, manufacturing process. Let me tell you again I am repeating this quotation. It is the duty of an engineer to bring the new thoughts and designs into reality by proper selection of material, method, manufacturing process, machine, etc. So what we required? Yes, we required the material. Without material, there is no manufacturing. So on material only you have to do the manufacturing process. And second one is, which method is suitable? Which method is appropriate to do the manufacturing process? That is also very important. And the third one is machinery. Which machine I have to select? That is third one. And then manpower is also needed to operate the machine, to handle the workpiece, material, etc. And then investment, that is called money. So these 5 M's are very, very important. See here, we are giving as an input, as a method, we are selecting a method, machinery, material. These three we are giving as an input to the manufacturing process, and we are getting the final product. In between that, we are adding men and investment. Some investment is required. As I said, if you want to start a small scale industry, my dear friends, it is very simple. You have to purchase a 1 lathe and 1 HSS tool. You can do the miracles. You can do the multiple operations, wide range of operations, machining operations. So here these 5 M's will give you the final product, a required product. Now it is very important to understand the classifications of engineering materials. Materials plays an important role to construct a equipment or a tool or a product. And let me tell you, right selection of the material is much more important in the manufacturing field. If for example, I will tell you, in automobile car, if you take a automobile car, most of the material is constructed as a ductile material. Most of the material ductile. If you take a brittle material, immediately it will fracture. Immediately it will fracture. So right selection is important. And in coming to the aerodynamics, constructing an aeroplane, lightweight material is needed because easy lifting of that aeroplane. Lightweight, and it should be harder material so that the air pressure can be resist. So these are all the parameters to select a right engineering material. Let us discuss what are the engineering materials available in today's world. So I classified the materials in 3 categories. One is metals, non-metals, and materials due to combinations. Okay. Metals can be divided into 2 groups, ferrous and non-ferrous. Of course, all of you know that what is the difference between ferrous and non-ferrous. Which contains iron, it is ferrous material, which does not contain iron, it is non-ferrous material, as simple as it is. So, what is ferrous? Steels, iron, cast iron, rough iron, this all comes under the ferrous materials, and the non-ferrous materials, gold, silver, aluminium, copper, brass, bronze, these all comes under the non-ferrous materials. Okay. So, now it is your choice, okay, which material has to be selected based on the application of that product. Now, coming to the non-metals. Non-metals are two groups, ceramics and organic polymers. Ceramic materials, you know, in our washrooms we are widely using commodes and that washing sinks, etc. These all comes the ceramic, good heat resistance, and there is no corrosion. Okay, that is why we are using the ceramic materials. Coming to the organic polymers, plastics, plastic, polyethylene. Okay. Of course, polyethylene is a little harmful to the earth. So, kindly you reduce to using the polyethylene materials. So, plastics, etc. Now, coming to the material due to combination. So, materials due to combination means you are adding two or more materials together, to form a new material. You can ask me the doubt, sir, I will fabricate a new material. I will take 2-3 materials, I will fabricate it. My dear friends, let me tell you, here one condition apply, that is all material should satisfy the material properties, that is mechanical properties, thermal properties. These all properties, if it satisfies, then only we can call it as a material or metal. Okay? Right. So, here composites, there are plenty of composites. Many researchers are working, many engineers are working to bring the new composite materials in today's world. And most of the, you can see the natural fiber materials are nowadays using in the automobile also. You can see in our car door, most of the car door material is constructed by the composite materials only. So, natural fiber reinforced plastics are using widely in automobile doors. You can see the automobile doors, okay, and then material reinforced metal. So, you can add some metals into the composites to form a composite. Natural fiber you can take or some other material you can add, but the condition apply, that is all materials should satisfy the material properties. Now, coming to the alloys, it is very simple. It is a inconel alloy, nickel based super alloy, aluminium alloy. Most of the times we are hearing that word. What is alloy? It's simple, my dear friends, mixing of two or more metals. Here there is no natural fiber or plastic, etc. Alloy means two or more metals will join together. Okay. So, here what I will give you a small example. What is 24 karat gold and 22 karat gold? Simple, impurities. If there are more impurities, it is 22 karat. It is less impurities, then it is a 24 karat. So, what are the impurities will be added in the gold? Non-ferrous only, because gold is a non-ferrous, that is why non-ferrous. If ferrous material will be added, corrosion will start or rusting will form, right. So, which metals to join together, it is also very important aspect, my dear friends. So, alloys means again two alloys, ferrous and non-ferrous. As I said, ferrous alloys means of course iron content in the iron content is there, and non-ferrous means there is no iron content. Okay. So, these are the broadly you can tell that engineering materials, these are the broadly classified engineering materials. So, in manufacturing platform you are using these all materials. So, now classifications of manufacturing, very important. For easy understanding, let me tell you, for your easy understanding there are 3 you should remember. For easy understanding, please do not write this one anywhere, okay. For your understanding, easy understanding, let me tell you this one. There are three classifications of manufacturing. There are three aspects. One is -1, 0, +1. If you remember this one, you know the classifications of manufacturing process. Then what is -1? Material removal process. We are removing the unwanted material to produce the final product. That is comes under the material removal process. What is 0 then? Material constant process. We are not adding any material, or we are not removing any material here. We are changing the shape of the product. I will give you the example soon, don't worry. So, we are not adding, we are not removing the material, it comes under the material constant process. And third one, material adding process, that is +1. So, what is +1? Material adding process. Don't write -1, 0, +1, okay. This is for your easy understanding, I told. So, material adding process, we are adding the material. We are adding the material to get the final product. And you can see the broadly I classified here the machining. In material removal process, one of the major operation is machining operation, and this machining can be divided into two groups. One is conventional machining and another one is non-conventional machining. Sir, what is difference between this conventional and non-conventional? Very simple, again very simple. In conventional machining, tool is directly touched to the workpiece to remove the unwanted material. The first condition of conventional machining is tool is directly touched to the workpiece to remove the unwanted material. And the second condition is in conventional machining, the second condition is tool should be harder than the workpiece material. Tool should be harder than the workpiece material. These two conditions apply in conventional machining operation. And what is not non-conventional? Not required. Tool will not touch to the workpiece. Tool will not touch to the workpiece, and tool should not be harder than the workpiece material. Advantage: if tool is harder than the workpiece material, imagine if it is a workpiece is a harder material, how much harder tool you have to select in conventional machining. So, that condition is not applied here in non-conventional. So, tool should not be harder than the workpiece material. Then how we are removing, sir? Tool is not touching and tool is not harder than the workpiece. How we are removing the unwanted material? We are using the different energies. What are that energies? Mechanical energy, electrical energy, thermal energy, chemical energy, etc. In mechanical energy, there are multiple processes like unconventional machining, abrasive jet machining, water jet machining, water abrasive jet machining. And electrical, there are electrochemical machining. These all the non-conventional machining operation. Now, coming to the material constant process. In material constant process, metal forming operation. We are not removing any material, we are not adding any material, but we are changing the shape of the product based on our requirement. So, what we are doing here? Very simple again. You can see in the market AXA blade. How AXA blade will be manufactured? Heating the material and applying the forces. Heating the material and applying the forces. We are changing the shape of the product. Very simple. That is called forging. You understood one operation in the manufacturing. Forging. So, we are heating the material and applying the external forces on it so that it is changing its shape. But here you should understand one point, that is recrystallization temperature. So, how much heat should be? Sir, how much I have to heat the material to apply the forces? That is called recrystallization temperature, which means in the material there is a crystals will be rearranged. So, recrystallize above the heat, above the recrystallization temperature. Generally every material, for example, let us take for some X material is having 1000 degrees centigrade of the melting point, then up to 700 degrees centigrade means 700 degrees centigrade is the recrystallization temperature. Okay. So, similarly, you can calculate if 1000 degrees is a melting point of the material, then 20 the 700 is the recrystallization temperature. So, we are heating it and we are applying the forces. The forging is there, rolling, high rollers are passing through that recrystallization temperatured material on the material, whatever the material it is. And extrusion, very simple example, toothpaste, you are using the toothpaste, isn't it? You press the toothpaste, whatever the outlet shape you have given, generally it will be cylindrical. So, whatever the shape you have given, similar shape will be coming out. So, extrusion process. And sheet metal operations, you are using multiple sheet metals operations. Now, the third one is material adding process, very important. As I can say, this is the pen, you can see here, I am just removing this cap, okay, and I am removing this particular thing. For constructing a small pen, you are having these many of joints, okay. So, you are joining like this, these many of joints. Imagine in an automobile car, imagine a aeroplane, imagine a ship, imagine a tankers, which is widely used in the petrochemical sectors. My dear friends, let me tell you, material adding process is also very important. So, in material adding process, the material joining process will be there. Again, it will be divided into two groups, one is permanent joint and another one is temporary joint. This is the temporary, I can remove it and I can assemble it, temporary joint. Bolt and nut, temporary joint. What is permanent then? As simple as it is, welding operation. Technically, what is the difference? Let me tell you, what is the difference between technical sentence, if I want to tell the difference between the permanent and temporary. It is very simple, that in permanent, once you join two sheets or two plates, if you want to dismantle it, if you want to remove that joint, it will not come to its original shape or original size. But in temporary, original size and original shape, right? That is the basic difference. These are the basic classifications of manufacturing process. Now, here we are focusing only on conventional machining process, my dear friends. We are using this one as the conventional machining process. Here you can see that we are using only the conventional machining process. What is that conventional machining? Here we have gone through this one. This is the conventional machining process. In conventional machining, there is turning, milling, drilling, threading, shaping, planing, grinding. There are melting. Again, I will tell you, manufacturing is a ocean and these all are seas, right? Okay, this material removal process, material constant process, these are seas. So, in this turning, milling, so we are now focusing on this particular conventional machining process. What is machining? What is machining process? So, let us understand this. Machining process means we are removing the unwanted material. We are removing the unwanted material to produce a desired product or a desired shape or a finished product, which is useful to us. So, it is very important. You can ask me, sir, why it is important than other manufacturing processes? After casting, my dear friends, I have not mentioned in the classifications of manufacturing the casting, but casting comes under the material adding process only, but it is a separate category. That is why I have not shown here. Why it is separate category? Because based on how much skilled you are, you can reduce the wastage in casting operation. If you are much skilled in casting operation, you can reduce the wastage. And you have to add extra material in casting operation. Why? Sir, why? Because we are giving shrinkage elements, we are giving distortion elements, draft elements, and finally we are giving finishing elements, that is also called machining elements. So, after casting also, you need some machining process to get the finished product, a finished product. Similarly, in the forming, some of the forming objects also required machining operation, finishing operations. right. So, in machining operation, as I said, removing of the unwanted material to produce the desired product. Okay. So, where we are doing on a material. So, that is why it is called material machining or metal cutting or metal machining operation. The raw material which we are using, a rod, a cylindrical rod, for example, some X person and Z person is there. X person need a 100 mm diameter, and the Z person need 95 mm. So, you have taken 200 to 110 diameter of the rod, and you are removing the 10 mm for X and 15 mm for Z. So, removing the unwanted material, and the base, the first workpiece is called raw material, and the unwanted material will be removed as a chips. It is called chips or scrap. Generally, it is called chips. The device which you are using to remove this material, the device or equipment is called the machine tool. Cutting tool is different and machine tool is different. Cutting tool is remove the material, but machine tool is whole equipment is called machine tool. Now, here we are focusing, our title is one machine and one tool. We are focusing that one machine as a lathe. I am not going in deep of this all specifications of the lathe, but let me tell you 4 or 5 parts of this very important. The one is, you can see here the headstock. The first one is, you can see the headstock. All the cutting processes will be there, and this is called the bed. The lathe size will be depends upon the bed size and the chuck, how much diameter it can hold. These two processes, the bed size, this is the tailstock, that dead center of the workpiece will be holded here, and this is a lead screw and feed screw both. For threading, we are using the lead screw, and we are changing the feed screw when continuous turning will be there. So, this is called the lathe. If you have one lathe and one HSS tool bit, if you know the tool signature, then my dear friends, it is more than enough to start a small startup, and it is always suggestible to start a small, you can start your startup from small scale industry to large scale industry, and it will gives you a beautiful startup. Now, you can see I have shown here different parts of the lathe. Now, I am showing here, if you take a single point cutting tool, that is enough, and you should have an idea of tool signature or tool nomenclature. What is side rake angle, back rake angle, end cutting edge angle, phase, these all you should have an idea, so that if you take one tool and you can just grind it based on your requirement, you can change whatever operation is there, according to that you can change this one. This edge you can change, that is called the nomenclatures of the tool. If you understand the basic nomenclatures of this tool, easy, you can change it, you can grind it, you can change the tool signature, whatever the operation you want to do. So, this is the tool bit which I am talking about. It is cost about 250 rupees, and the lathe, it is all about hardly below 5 lakh or below 10 lakh based on the bed size, and you can start within 10 lakh, you can start a beautiful startup in your this machining operation. Sir, what are the machining operations will be done on the lathe? I will show you that figure finally, and very important, you have to choose 3 input parameters. What are the 3 input parameters? That is, you have to give the machine tool, that is cutting speed, feed and depth of cut. Cutting speed is very simple. Workpiece is rotating, tool tip is there, workpiece is rotating. In 1 minute, how many rotations happened, or how much workpiece has been travelled with respect to this point, that is called cutting speed. It is meter per minute. And feed is how much distance tool has been travelled through the workpiece, that is called the feed. It is expressed as mm per revolution. In one complete revolution of the workpiece, how much tool has been travelled, that is called feed. And depth of cut, how much depth you required to remove the unwanted material, that is depth of cut. Now, let us see here. I can say there are multiple operations on a single rod, and my dear friends, let me tell you, we have used most of the operation one tool and only the lathe, one machine tool, one cutting tool and one machine tool. So, from here onwards I am just telling, I am just giving you the names of the particular operations. First we have done the what is called the facing operation. Two ends of the workpiece, this end and this end, we have done the facing operation. Then this one is the step turning. You can see here there is a graduation marking for measuring operation, for measuring, and this is straight knurling, gripping process, and this one is taper turning. Based on the applications we are doing the taper turning operation. Then again this is a straight knurling, and this is the BSP thread, British Standard Pipe, using in chemical industries, aviation industries, almost all shipyards, etc. And then it is the this is called as a BSP thread and buttress thread. This is called the buttress thread, right? And this is concave turning, right? And this is knuckle thread, spur gear, and this one you can see here acme thread, and this one is the what you call the square thread, and this is diamond knurling, and this is BSW, British Standard Whitworth, and this is again BSW left hand and BSW right hand. Here you can see each and every operation we have given the space in the form of grooving, and then after plane turning, and here you can see V pulley drive, and of course we have done the drilling and the internal threading. For drilling and internal threading we have used the drilling machine, except all other we have used the lathe operation and a single point cutting tool, except this knurling. Knurling tool is different. So, we have taken one single tool, we know the tool signature, and we continuously changing this tool signature based on the operations, and we perform the multi operation on a single rod. Let me tell you, almost all 20 operation, 20 various machining operations we have performed on by using one single tool and one machine tool, that is lathe and HSS drill bit. This is the operations which just we have discussed. There are multiple applications, as I said, aviation department, petrochemicals, automobile engineering, and all other shipyards, aerospace, and all chemical industry, petrochemical industry, defense industry. These all operations is required. My dear friends, as I said, the joints, what are the joints is made in the aviation department, in aviation sector or automobile sector, these all threads will be used and all operations will be used in the manufacturing industries. What are the operations performed on the this workpiece, okay, and what are the applications? As I said, multiple applications are there. If you start a small startup, even a chemical industry, if you want to form a shed, industrial sheds, then also you need this type of operations. So, let us see practically how this rod looks. This is facing, this is chamfering, this edge is chamfering, step turning, you can see the step here, and this is the graduation marking, and this one here you can see the straight knurling operation. This one is taper turning, and again this is a straight knurling operation. This is BSP thread, and then it is a straight knurling. BSP means it is a British Standard Pipe, and this is straight knurling. Again this is a buttress thread, you can see here, and then it is a concave turning, and here it is a knuckle thread, and then this is a spur gear, and here you can see the acme thread, and this is convex turning, and this is the square thread, and this is the diamond knurling operation. This is BSW left hand, and this is again straight diamond knurling, and this is again the right hand of the BSW this is grooving operation. You can see the small slot here, it is a grooving operation, and this is the plane turning. Then this is V pulley drive. Then you can see here the drilling operation and internal threads. So with this, I conclude here my class. Thank you so much for listening.